Uh, all right. Okay. Hi to everyone who's here. I There's not like very much point to starting new stuff today, I guess. Uh, but we'll wrap up what we've done last time, and then we'll talk about project one, and then if we're done, I'll just let you go, I guess, and then we'll start fresh after the calculus test tomorrow. So, okay. So this is where we were at last time. So what we're trying to do was to basically make a mechanism for using strings in C the way you would in Python. So I want to be able to say something like append strings S1, S2, and make it be kind of like S1 plus S2. So the overall architecture here is that in myString.h, what we do is, for now, we've defined the structure. So the structure was, we have a string and we have like the contents of the string, and then also we can keep track of the actual length of the string, as well of the size of the buffer. So the buffer would be the actual characters. The length would be how many characters until the null, and this is how many characters in total, including the null, can you store in the string if you wanted to. Okay. So we also said we want to be able to use the function create string. So if you've done the lab on Monday, then you know. But if you forgot from Monday, then the way we do this is we say this is where we say where the prototype of the function is. So this is called the prototype or the signature. So this is not the function definition. This is just saying, I promise you that there is going to be a function like that somewhere. And then we actually implemented in myString.h, in the .c file. So of course, myString is just a name. The point is, in the C files, we have the actual implementations. In the H files, we just have the prototypes. And one use of the .h file is that you keep it consistent, right? So if I say include myString.h over here, then if I decide to mess up the signature here somehow, so I, just say, like I also have like an int b or something, that would then just not compile because that's not going to be consistent. Okay. So that's one use. The other use of it is that in the file use strings, which could be anything that uses strings, I can just say include my str.h, and then I can compile this together with my str.c in order to make it work. Okay. So very often what they see is people saying something like include my str.c. And that's not illegal. In fact, sometimes it would work. So if you do this, instead of this, it could work, because what this basically does is it says, take the entire contents of this guy and then just paste it here. That's completely fine and legal. It's just that so the way you would compile it is you would compile it with use strs.c, and depending on how you set it up exactly, it could work. So here you see it does actually work, so it gives you some warnings, but that's fine. You cannot say use strings.c and also mystr.c because that would be defining the thing twice. So that would actually produce an error. Let's scroll up to see where the error is. Yeah, so it was like somewhere there. So one of those was an actual error because you are defining the function create string twice, right? And that's just because you're saying, so grep just found the line there, which I was like too lazy to find when I was scrolling up. So if you're saying this, that would just be basically including this code twice. The second time that GCC sees it, it's a problem. So it's just it's better practice to just literally never do something like this. If you want to include a C file, we ran out of battery. And as per usual, there's no more batteries. Okay. All
Your
right.
call is being connected.
Okay, I will try to speak more loudly. If you can't hear me in the back, the only technological solution is to move yourself forward. Okay. So yeah, so basically just never do this. This is the pattern, and this is despite the fact that if you're careful about it, you can make it work. Just like no point in doing it like that. All right, make sense? All right. So that was the setup. And then to remind you, if I want to run it, I go to configure tasks. So if I do like control minus, that would be over here. Go to configure tasks. Hello, we are out of the AA batteries.
Yeah, sure. I'd send someone to drop more batteries.
Thank you very much. All right.
Thank you.
Thank you. I'm not crazy. There is a microphone here. Okay. And so, okay. So to remind you, the way it works is here, when you say configure tasks, what you're saying is for this folder, which I opened. So you'll notice that I have the lecture folder open. The command to compile is GCC. So this will be a little bit different depending on the computer. And then it's saying currently compile the current file. So $file means current file. In the same way that here it's saying the program name is going to be the current file, but without the .c. Okay, so instead of saying this, I will say, so mystr.c, and I'll say before that, although the order doesn't really matter, use strings.c. So if I do it like this, so the way the configure tasks work, things work is that the last thing, so like I changed it a bunch of times. So the last thing is the thing that's relevant. So if you just do configure tasks, it'll take you to the new current configuration. So if I go here and I go to use strings, that will now run. And once it does, if you go to the terminal, problems. Okay, this is just implicit declaration. That's fine. So let me run it again. So I'll print S1 buffer. This is an implicit declaration. Okay, and here it printed the high. So sorry, I'm looking for. Yeah, so this is the compilation, and you'll see that the compilation command is so GCC use strings, my strings, and then the output is use strings. That's the name of the program. Okay, so that's from the configuration. VS Code basically just built this command and ran it. Make sense? All right. Let me get rid of the warnings. So here printf was underlined because I did not include stdio.h. So IO stands for input output. And then it was also not happy that I used strcpy without including string.h. So if you're on Windows, ordinarily it would just not compile if you don't include it. But on Linux, it's just complaining, but actually it works fine. So that would be like this, and that should get rid of those eventually. So if I compile again, that should compile without any warnings. Okay. All right. So I want to now write append strings. So let me see how I wanted to use it. So I wanted to say append strings S1, S2, and I wanted to return a new string. And they wanted to return a new string from append strings. So let me first define a signature that corresponds to this. So it should return a myString star. And it takes myString star S1 and myString star S2, like this. Okay, let me. All right. Make it load. Make sense? So now I want to actually write it. So this would be like this. So what do I need to do here? I need to create the new myString. The space doesn't really matter. This is just like a style thing. It would work either way. So I need to create a new string, and then I need to make the string from S1 and S2. So I have a function to create a string, right? So I'll say my string results is going to be initially nothing, then I'll create it. So I'll say create string. This is going to be address of res. That's because create string takes a pointer to my string star. And here I got to choose what to do. So I could just say initially it's going to be nothing, or I could build a string first and then just send it when I'm creating res. So let me create the string first. So in order to create it, I need a separate buffer, not super efficient, but whatever. So I'll say, okay, and that should be a buffer that's enough space to contain both S1 and S2, right? So that means that I need S1 length plus S2 length plus 1 for the null, right? So once I have this, I just copy the contents of S1 and S2 into the buffer. So the easiest way is to use the string functions. There's multiple, you could also do a for loop or whatever, that's slightly more efficient. But I could just say strcpy, so into buffer from S1 buffer. So now the buffer that I just made contains the contents of S1 buffer up until the null. And now I can strcat the buffer and S2 buffer. And that copies the contents of S2 buffer to the end of just the plain buffer. Now that I've done it, I can send the buffer over here. So res is now created. And I can now return res. Does that make sense? So I think kind of the individual lines should be pretty straightforward. I think for many of you, this will look like, okay, there were like many choices and it was unclear how to make those choices. And that is just true because like you could choose a different implementation, right? So the one that I chose is just like the one with the least fuss, just like using kind of the existing strcats, whatever, right? So again, what we've done is we've just like made a buffer which is like separate from what will be in the string eventually. We build it up to have the contents of S1 plus S2. Once we did it, we create result and we just copy in here this buffer, which is a temporary thing. Thank you very much.
No worries. Or just like an extra pair.
Thank you. I'm sure the next person will appreciate it. Thank you. Yeah. Right. But they didn't leave a box, so that means that nobody's gonna know which ones are the used batteries. I'll take them with me. All right. Question so far, is that okay? All right. So now that we've done it, we can go back to use strings and try it. So this is going to be S3. So I need to create a new one. So this would be like S2 is calc. So I'll just do it like that. So if you wanted to, you can do like my string with a comma, but it's kind of confusing, so I just won't. So that's like this. And now I can do S3 is equal to S1 plus S2. And I'll now try to print S3 buffer, like so. And here you go, it worked. So you can kind of have the plus for the strings. Why am I doing all of this if I have strcat? Well, because strcat doesn't actually account for the fact that you need to know how much space there is and whether there is enough space to actually copy to the original string. So I'm hiding those details, right? So that's kind of the point. Does that make sense? Okay. So the downside is that this is gonna create problems with Valgrind because I kind of was like mallocing stuff like crazy without ever freeing it. So if I run it with Valgrind, is use strings. That is creating a lot of memory leaks. So let's clean it up as you should for project one. So one thing that I've done where I did not clean it is I created a temporary buffer here, but I never actually freed it. So once I've used it up, here actually copy it to this buffer. I should free it. So this would be like this. So note that the reason it's like that is because of the specific design of the create string function. So here I'm strcpying it. I could, in principle, instead say star ps like so, right? So that would also be a design that could work. What would be a downside of doing it like this? So it's a little bit subtle. So one downside is that if I want to be able to both send in a string literal and send in something that's mallocked, that's a problem because then I cannot free it easily because I don't know whether the thing is a string literal or a malloc thing that I'm eventually supposed to free if all I'm doing is just using the string structure. Right? Another downside is that if I do it like this, I'm potentially creating aliases that I cannot really keep track of, right? So I'm creating this buffer over here. And then if I'm just saying, I'm just going to use this buffer for whatever, that would be that would be an issue if I then modify this buffer without remembering that actually it's connected to the buffer in res. A third downside is that if I accidentally send an array as init, and then I return from the function, that array is gone. I'm not allowed to access it. So all sorts of issues. Does that make sense? Let's just kind of to make sure, I'll do an example. So if I say something like this, And then I do, my STRS, and I do create string. Like this. And then I return S. So that's the same structure as append string. Then with this structure, this would create major issues because it would run just fine, but then if you try to access as a buffer, that would crash. Because str only exists while the function issue is running. Does that make sense? On the other hand, if you do it like this, then that's completely fine because you're only using the contents of str, and once create string has finished running, it doesn't matter that str was a character array. You already copied its contents, str is gone, that's fine. All right. So, okay. So here, this is completely fine. So let's also deal with the other thing. Which is freeing. So this is something that we've done before already. So in order to free this kind of structure, the structure is over here. You need to free the buffer first, and then you can free the structure. And that's, of course, assuming that the buffer was mallocked, which is what we always do. So it's fine. So here, in order to free it, you'll say free S1 buffer. And then you'll free S1. So that's the exact same thing that we've already done with this kind of structure. Again, this assumes that S1 buffer was allocated with malloc, which we make sure to do. Okay. So, all right. So in order to use this, we'll move this guy into my strh as well. Like so. And then in use strings, we'll destroy S1 and S2 and S3 before we finish running the program in order to get rid of the memory leaks. So this is like this. I'll run it. So I'm running it even though I don't really want the output. I just want to recompile so that I can then use Valgrind. And we're completely fine. So to be clear, so if I forgot to do this, it would not be fine. So here we have S3 that's lost. And also if I forgot to do the free buffer over here, I would also not be fine because every time I'm appending, I'm neglecting to free the temporary buffer, so that would also make it so that there is a leak. Here we have this as lost. All right. Cool. So that's that. So you can do kind of various things. I think what you mostly do with strings is you add them. A nice thing about the strings that we made here, as opposed to Python strings, is that those are actually mutable. So that means that you do get to do something like S3 buffer at 0 is equal to H. And now you can print this guy. And that's completely allowed and fine. So that is arguably better than the Python strings. Right? They work the same way as the Python strings with respect to aliasing. So you can say something like, or rather the same way that Python strings would work with respect to aliasing if they were mutable and it were relevant, right? So if you say something like my str s4 is equal to s3, that is allowed. So you might be slightly confused by the fact that there is a star here, but not here, but that's completely fine, because really what this is saying is S4 is of type myString star, and then S3 is also of type myString star. So saying S4 equals to S3 is completely legit. And this just means that S3 and S4 are both addresses of the same string. So that means that if you multiply the contents of one, you also multiply the contents of the other. So that means that if you go and say S4 buffer 0 is capital H again, then if I print S3 and S4, I'll again get high calculus with the capital H. Make sense? So that's equivalent to kind of having Python code that's kind of like this. That's kind of the deal. So this in Python does exactly the same thing as what we have on lines 1920, is you make L and L1 aliases, and then you modify the contents of one, you also modify the contents of the other. This is exactly what we're doing with the C strings. It would have worked like this with Python strings as well. The issue with Python strings is just that this is not a legal thing to do with the Python strings. So, but like the issue is this completely does happen. Does that make sense? Questions? All right, so that's kind of neat. You would usually implement kind of other things as well. So because you can actually like resize the strings, you can imagine doing something more efficient where you kind of resize the buffer, but that we will leave for later. All right. So this is this. So the other thing that I wanted to do today was introduce project one. So so as announced on Piazza, it's due so the end of next week. I don't, so I made it due like 11:59. I also gave you like 3 free grace days. So the idea being that if you really have to, you can do it by Saturday. But like very obviously, you should do it before, because there is a midterm on the following Monday. So, and like doing project one is the best preparation that you can have for the midterm. If you look at the previous midterms, like a lot of the questions are very much like parts of the project. There's like obviously also other questions, but that's like the labs and the projects and basically it. So we'll talk more about the midterm in the coming 4 lectures, which we still have. All right. All right. So this is the project. Please note that it has to not have issues with memory, or we take away 2.5% from you. So I understand that like not everyone has Valgrind installed. So Valgrind is now available on Gradescope. So it's also going to be in the it's also going to be in the in the project one autograder, but you can just go to the run Valgrind assignment, and then here you can submit anything you want, and it will give you the Valgrind output for that. So let me show you how that works. So, of course, kind of Gradescope doesn't know anything about the thing that you're submitting, which means that you need to submit all the files. So, for example, I could submit like use strings and mystr.c and mystr.h. Right, so that would be my entire project. Sharing a window. So unfortunately, it takes a while. So basically what we do in the background is like we basically made the autograder just be run the thing that you're submitting and dump the Valgrind output, and you'll get the Valgrind output like this. So this is one way to run Valgrind. It's unfortunately not as smooth as doing it on your own computer if you have it installed, because it takes like 5 seconds, but that's like the best I can do. Make sense? So, okay. So that was the logistics. So the project itself is like this. So you're given a list of terms. So here the list of terms is like cities with populations. So populations are like notoriously weird because like so Shanghai is also like genuinely a very big city, but depending on like how the municipal boundaries are considered, like, you know, we could have like a small cities with a lot of suburbs or whatever. Anyways, so you have that. And then what you want to do is you want to input the first characters of the term, and you want to get a list that matches the characters that you enter, but sorted by the weight of the term. So in this case, the weight is just the populations. So if you enter like whatever TOR, you want to get Toronto first, and then you want to get like the next thing that matches TOR. Bad example because all of those are not, they don't like start with TOR. Try to look for like SAH or something. So yeah, so like if you enter like SHA, you want to get like Shanghai first, and then the next city by population that starts with SAH, it's probably not Shanghai. Okay, I got unlucky with doing SAH because none of those actually start with SAH. But anyway, eventually you'd find something that starts with SAH. All right. So, okay. So that's the goal. So the way you implement it is like this. So you read in the file, and the way you read in the file is it's going to be a block of terms like this. So you read it, so you basically read it as a loop. There's code to do that. You read the strings into the term, and then you read the weights into the weight. So in the lab this week, you have actually like lots of examples of how to read in those numbers. This has to be a double just because the weights can get too large for integers to sort. So we make them double. So this would be the read in terms function. And then the idea is you sort them alphabetically so that you can quickly find the first city that matches SAH and the last city that matches SAH. So that you can do with binary search deluxe from project 2. Right. So, and that you can do in log n time, because if everything is sorted alphabetically, you can find the range of like everything that starts with SAH, everything that ends with SAH. Once you do that, you take those things, they're sorted alphabetically, you want to resort them by weight. Because the way the autocomplete works is you want to output the terms with the highest weight first. So the way you sort them is with qsort. So one of the things that you need to do for the assignment is figure out how to use qsort in order to sort those kinds of things. Read the documentation. It's not hard. Please do read the documentation because ChatGPT is not going to be available for the midterms. So knowing how to use qsort is like definitely fair game for the midterm. And like it's not hard, but you need to read it. All right. So that is basically that. It's the same thing from 180, follow the instructions. So you only submit autocomplete.c. We compile it with our own autocomplete.h, which is given to you, which is how we make it so that we can actually run the autograder, right? We make it so that it just wouldn't compile unless you use the specific format that's in autocomplete.h. Yeah. It actually, so you don't need to count them because it actually says in the file how many terms there are. That's the first line. Yeah. 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 Yeah, exactly. Yeah. Yeah. So otherwise, it's kind of annoying to do because the only way to like you can count the number of lines in the file. It's just that it's annoying to do because like you need to go through the file and then eventually you get to the last line and then you know how many lines and then you need to start from scratch once you know how many items. So it's kind of annoying. Or, I mean, that's one way. All right. All right. Other questions? Yeah.
Just on Gradescope about like online exercise 1.
Yeah. Like I said on Piazza, I decided that everyone gets credit for exercise 1 because the project is due too soon. So there's gonna be like we actually made the exercise. I just like decided not to assign it, so it's going to be like a not for credit kind of thing.
Oh, so
yeah,
we're just gonna leave that one.
Yeah. Yeah.
Release, we need to deploy the technology. But that's not in the header file. We just implement those in our open environment. We need in the header file.
So if you notice, you can't actually destroy the term over here because of the format. There's like nothing to destroy, right? So the term, there's no malloc inside. So what you have is you have a block of the terms, but that you do that you do like in your functions, right? So if this were like a car star which you malloc, that would be an issue, but it's not. All right. Okay. I will see you in 23 hours when you'll be probably much happier. All right. See ya. Bye.